Hello guys, this is Jack Calvin Rogers III with the lab video for motion, uniform and non-uniform motion. This class is 114, Physics 114, and the teacher is Dr. Azita Fadei, and the date is 30 April 2019. So in this lab video, we're going to explore the concepts of both uniform and non-uniform motion. Uniform motion can be described as a displacement of an object at a constant rate from a starting point to an endpoint. Non-uniform motion can be described as the displacement of an object at a rate that changes from a starting point to the endpoint. In this video, we're going to explore the differences between both types of motions. All right, so first we're going to show you a video example of both uniform and non-uniform motion. Then using raw data gained prior to with Logger Pro, we'll compare the two types of motion. And then using refined motion and time graphs, we'll determine an actual conclusion. And so here we're seeing an example of uniform motion. And let me get this playing for you. All right, one more time. All right, and once more. All right. Okay, and remember this was a uniform motion. And here's the example of non-uniform motion, which is just a girl tossing a ball up in the air. All right, and once more. And a third time. All right, let's just real quick. Here's some notes about Logger Pro. It's a video analysis program that allows us to gain valuable data in regards to the motion of an object. At minute time intervals, we log the position of an object as it's displaced, and what Logger Pro will do is it will create some very nicely done graphs for us that show us different factors, and you can play around with that data. But just for today, we'll just do motion time graphs for now. So here's our raw data from the uniform motion. As you can see, there's the table to the left that shows x and y, x, y, x velocity, y velocity, the amount of time that was logged, and then and this is all for uniform motion. And here is raw data from non-uniform motion, or this is the ball toss. And it's the exact same amount of information as the last graph. And then here is the refined graph. So it'll kind of help us out a little bit more. So here's the uniform motion right here. And this right here is the non-uniform motion. All right, and here's the tables in a little bit more detail. As you can see that this right here, this one right here is going to be the non-uniform motion. Here on the left, and the uniform motion is there on the right side of your screen. As you can see, they're both kind of short. That's not a lot of time. You don't think it's a lot of time. How much data can you get from 3 seconds? A little bit less than 4 seconds. Well, that's quite a bit of information that you can gain from such a short amount of time. So here's some things to consider. The slope of 2 points is directly correlated to the speed of the object being displaced. So, and since with that, we can determine the type of motion happening based upon the slope shown in a line graph. So we're gonna take a quick look at the refined graphs All right. So here you can see I sloppily drew a line uh, through for uniform motion, and what we can mostly see up until I got a little lazy and curved there. So I'm just going to draw a line here and here. Other than a little bit of human error for me, is this is generally a straight line, right? So this is not, there's no change in the slope of the line at all. And this is for uniform, again, this is for uniform motion. So we can see from the slope of the line that the speed is constant. And when we look at non-uniform motion, let's go from here to here. Even just this one, you can just determine just by this one particular section of slope. This is not uniform. So this is not really forming a straight line. So what do I mean by straight line? So let me show you real quick. So we start at this point, and we're drawing a line, and that looks straight. But let's draw another line, and we can see that the slope is not even. All right. So what does that mean? It means that the speed of the car is constant throughout the displacement. That means that the car is in uniform motion. The car is going from point A to point B at a single consistent speed, right, or velocity. The speed of the ball is actually fluctuating during displacement, showing that the ball is in ununiform motion. So here's our conclusion. In this lab, in this lab presentation, we viewed two objects displaying uniform and non-uniform motion. Using data gathered, we analyzed their motion and determined that the car was in uniform motion and the ball was in ununiform motion. Any potential errors were made from improper use of equipment, such as my slightly squiggly lines, and the limitations of equipment on hand. The goal of showing the difference between uniform and ununiform motion was made, and all findings reflect the law of physics. And here is the link to the videos that I use. Here's the link to the car in motion, and this is the video to the ball toss. And that concludes our lab report video.